Today's episode is brought to you by Name Audio, the iconic British hi-fi brand. Name recently launched a new premium wood edition of their award-winning Muso 2nd Generation, the wireless speaker system that excels with music and TV. Discover the Name difference at NAIMAUDIO.com. Today's episode is also sponsored by SCHIIT Audio. SCHIIT Audio designs and builds audio components in California. Based in Valencia, their wide line of amps, DACs, and audio accessories fit any budget, starting at $49. For a full rundown of all their products, visit SCHIIT.com or stop by their retail store in Old Newhall, just north of Los Angeles. That's www.SCHIIT.com. Today's episode is also sponsored by INNOUS. INNOUS develops high-fidelity digital music players that are transforming the way we listen to music. Every nuance and detail is revealed, allowing one to experience their music like never before. Enjoy your own library of CDs and high-resolution files, and access to all the content in the world through streaming services and internet radio. All at your fingertips through an exceedingly simple user interface on a mobile device. Visit INNOUSdotCOM to learn more. That's www.INNOUS.com. All right, hey everybody, thanks for joining us. A very special topic today. I did a slight hand clap for fun there. But subwoofers and 2-channel audio, everything you ever wanted to know. And to help me kind of elaborate on this subject, we have the very smart, very subwoofer-inclined individual, Ed Mullen, Director of Technology from SVS. Ed, thanks so much for joining us.
Thank you, Brian, for having me.
So the reason I kind of want to talk about this subject is that I find that audiophiles tend to know a lot about their 2-channel speakers and even their surround sound speakers a lot, but the subject of subwoofer comes up, and it's a little bit more of a less known kind of topic of conversation that I think the audience could really, benefit from a little bit more education on. And as a guy who works hand in hand with this day in and day out, let's just start off, Ed, with subwoofer basics. Can we just kind of say what a subwoofer does and how can we kind of integrate that into a system in a very simplest term, like introduction style?
Well, 2-channel aficionados for years thought subwoofers were unnecessary in a 2-channel system and just ran their loudspeakers on full range. But even floor standing loudspeakers really don't reach the bottom registers of the bass that's in the recording. So a subwoofer really can bring some additional quality and dimension to even 2-channel users and we can achieve a really nice integration with the 2-channel system. So they're really gaining popularity. I've seen probably in the last 10 to 15 years a big increase in subwoofer use with 2-channel systems. So it's pretty commonplace now. We deal with 2 different types of subwoofers to answer your question, sealed and ported at SVS. The sealed subwoofers, as the name implies, have a completely sealed box, and they tend to be the choice for music applications and 2-channel users because they have a little bit better transient response and time domain behavior, less overhang. People would sort of characterize that subjectively as being tighter, more musical, faster. So those are that's the choice for a music application for 2-channel. The larger ported subwoofers, because the cabinet size is bigger and the porting system is present, do have higher output capability in the deepest frequencies, and that's just physics. And that makes them a good choice for filling a larger room at high volumes, and also maybe for home theater applications where you need to reproduce the LFE track and a lot of deep loud bass efficiently and play the system at commercial cinema type volumes that you would experience if you went to the movie theater. It doesn't mean that a sealed subwoofer can't give you a great experience for an AV system. It just means the ported system does have higher output capability than sealed for each family or product line that we offer.
That's actually that's very interesting. I hadn't really heard the discussion in relationship to two channel before. So you would say that you recommend a sealed for more musical applications.
Yes, absolutely. They just sound better, and again, subjectively have a tighter, more musical presentation than ported, less overhang, and they're also a little bit easier to integrate into a two-channel system with respect to their phase response. And the ported system has some phase changes that can challenge integration into a two-channel system. So that's another reason I like sealed.
So you mentioned phase. So in the very simplistic terms, I've noticed there's a phase switch on the back of most subwoofers. Can you kind of just delve into what that switch does and how to properly figure out which direction it should go?
What the phase control, there's a difference between a polarity switch, which is just between 0 and 180, and that is literally a reversal of the electrical signal being processed through the amplifier. And that polarity switch was pretty common for a few decades, and people called it a phase control, but it really isn't. It's either 0 or 180. There's nothing in between. A true phase control is usually infinitely adjustable if it's a rotary control, or would be selectable digitally in frequency increments, and it's adjustable between 0 and 180. So what the phase control does is it delays the signal being processed through the amplifier. And if the subwoofer is in a different part of the room and is arriving at the listening position at a different time than the loudspeakers, you can use the phase control to sort of time align the subwoofer and the loudspeakers so the presentation sounds more coherent and in sync or on time. If the subwoofer sounds like it's out of sync with the speakers, the phase control can often help achieve that integration.
So sometimes with the integration of a subwoofer, it just doesn't sound right. What specifically would you say are the things you would look for when you're trying to identify this irregularity in the timing with the subwoofer compared to the speakers that you hear? What does that sound like?
What it sounds like is the subwoofer's lagging behind the speakers, and that's one of the reasons why I do generally recommend starting with the phase control at 0, which is no additional delay at all. And really, you have to look at the phase response of the loudspeaker itself, because let's say, for example, you're running a ported loudspeaker, and maybe it's a bookshelf, and the port is tuned to 45 or 50 hertz. There's going to be a whole bunch of phase change and group delay at that frequency. It's just an inherent a function of the bass reflex design in the loudspeaker, and there may actually be more phase delay or phase rotation from the speaker than the subwoofer, right? So sometimes the speaker might sound like it's lagging, sometimes the sub might sound like it's lagging, and I would say trust your ears. Start at 0, and then adjust from 0 slowly through the. More than likely 180 is not going to result in the best integration, because then you're putting the subwoofer way behind the loudspeakers. But again, if the loudspeaker is exhibiting some phase delay just by virtue of the fact that it's a ported design, you can often achieve better integration by adding a little bit of phase delay on the subwoofer side.
That's really good, because I think we haven't really spoke about this at the top of the show, but I find this particular subject to be quite difficult because I've heard systems with really well integrated subs and the experience is seamless. That is the goal ultimately to me, is to get a sub in a system where it adds some beautiful low end that it's just not possible with a lot of full range. But yet, in my experience, if you just take a sub, drop it in the corner of the room, and hit play, you don't often get that experience. This is a tricky scenario from at least my take on things, where integration can be difficult, but done properly is highly rewarding.
I agree with you completely. The goal in a two-channel system with a subwoofer is a completely seamless transition from the loudspeaker to the subwoofer. It should sound like the loudspeakers suddenly gained additional extension. It should not sound like there's a subwoofer running in the system. And so that's the ultimate goal. If you can hear the subwoofer running by virtue of the fact that it's either too loud or the low pass filter frequency and slope is misadjusted, then you've failed in your attempt to integrate properly. Once it's done right and the time alignment is there and the low pass filter frequency and slope is adjusted correctly, then you get that seamless transition from speaker to subwoofer, and it's magic. I mean, you should really never even know there's a sub running in the system.
So we talked about one of the elements of that, which is this phase alignment switch. What were the two other characteristics that you meant in getting that going there? And then how do those kind of affect the system?
Well, we look at, like, say, for example, you have a ported loudspeaker, or maybe you're running a sealed loudspeaker. Both of those loudspeakers will have very different roll-off characteristics. And so let's look at the ported loudspeaker first. Say we have a bookshelf like we were talking about earlier. Good sized bookshelf, it's ported, it's a bass reflex design, maybe port tuning is 45 or 50 hertz. What happens to that bookshelf below port tuning is it will roll off in room acoustically at 24 dB per octave. That's just the natural roll off of a ported loudspeaker. And the nice thing about SVS subwoofers is that the low pass filter on our menu is adjustable for frequency and slope. And so the first step is to identify where is this loudspeaker rolling off in room, and that is your real starting point for the low pass filter frequency and slope setting. So if I was going to take a stab at this absent acoustic measurements, I mean, sometimes I'll just whip out the test rig and say, all right, let's see what this loudspeaker is actually doing in room, and that will allow me to integrate the subwoofer. But if I'm doing it by ear, I'd look up the specifications for the speaker, I'd say, all right, let's see what this speaker is doing in room. Where is it starting to roll off, and what is the roll-off slope? So again, using our ported loudspeaker example, it maybe starts rolling off at 45 or 50 hertz in room, 24 dB per octave. That would be my starting point for the low-pass filter, because you want to achieve slope parity on both sides. So if the loudspeaker's rolling off at 24, you want the subwoofer to roll off at 24. Really, you're trying to achieve what we refer to as an electrical acoustic crossover. The speaker's high passing itself. It's a natural acoustic high pass filter. It's just done, just rolling off. And so we say, all right, now we want to low pass the subwoofer at the same frequency and the same slope, such that there is a seamless transition from the loudspeaker to the subwoofer. Same slope, same phase rotation. You're not getting, phase cancellation or other anomalies. That's the goal, is to match the loudspeaker roll off with the low pass filter on the subwoofer. So our app and our menu allows you to select low pass slopes of 6, 12, 18, and 24 dB per octave, and 1 hertz granularity for the frequency. So you can really dial in the low pass filter on the subwoofer to perfectly match the roll off characteristics of the loudspeaker in the room.
That's very interesting. So in a way, you're saying the overlap between the two can cause inconsistencies in the smoothness of that transition. Is it reasonable to say then that they're not aligned, that there could be an accentuation at a frequency if it's one sloping down and then we come in at another angle, so to speak, that it doesn't sound as smooth generally, but also it could create an anomaly where it sounds irregular or bigger at that
sure
range.
Yeah, that's exactly what happens. Let's say, for example, we set the low pass filter at too high of a frequency. So let's say the speaker's rolling off at 50 hertz in room, 24 dB per octave, and we set the low pass to 80 hertz. So there's a big overlap between the subwoofer and the speaker. They're playing the same bass at the same time, from 80 hertz all the way down to 50 where the speaker starts rolling off, that is going to cause coloration and additional output over that bandwidth, and it's going to sound boomy in one note, and you're going to notice that the subwoofer is adding, this mid-bass boom or bloat to the presentation, and that's not the idea at all. The other half of that equation would be, let's say we set the low-pass filter too deep. Maybe we set it to 30 hertz, and now there's a big hole between the loudspeaker and the subwoofer. Loudspeaker's rolling off at 50, subwoofer doesn't come online until 30. There's a big hole between the two, and there's not a smooth transition, and the subwoofer's not supporting the mid-bass where the loudspeaker signs off.
Can we see any type of irregularities like that in the slope variable that you referred to as well, like the way it slopes off? If you're saying essentially the starting and the end point have to be roughly the same, but also the degradation at that point needs to match up. Otherwise, we're going to see some type of fluctuation there as well. Is that correct way of thinking about it?
Yeah, it's exactly correct. Let's say, for example, the other common alignment for a loudspeaker would be a sealed loudspeaker, a true sealed loudspeaker. Now that will roll off at 12 dB per octave instead of 24. So it's a much more gradual slope. And again, that's just the physics of the alignment of a sealed loudspeaker. And the roll-off frequency really is just a function of the cabinet size. So say you've got a mid-size sealed loudspeaker, it's probably going to roll off somewhere in the mid-bass region, but it will be a much more gradual roll-off slope. Again, 12 dB per octave instead of 24. And then you would have to set the subwoofer low-pass slope to 12 to match the roll-off slope of the speaker. Again, you're looking for slope symmetry on both sides, phase symmetry on both sides, and you would set the frequency of the low-pass filter to match where the loudspeaker itself starts rolling off in room. Again, that's easier to do with a test measurement, but you can also do it by ear. You can just run a little frequency response sweep, like a sine sweep or something like that from YouTube or some other online source, and just listen to where the speaker obviously starts to sign off and lose output, and note that frequency and say, all right, that's a fair starting point for setting the low pass filter and slope, and then you would just go by ear there. But more than likely, you're not going to be more than maybe 5 hertz off from your final setting if you do that as a starting tactic.
Is there any way to determine the roll-offs, the slope, as you're saying, by ear without measurements, or is that something more just like it is what it is at a lot of points?
It is what it is. Again, a ported speaker is going to roll off at 24 dB per octave. A sealed speaker will roll off at 12 dB per octave. So those are the two most common slopes that you would pick in the low-pass filter when you're integrating the subwoofer with the speaker. I mean, are there exceptions where asymmetry ends up with a better integration? Sometimes. Again, I would do that if I was actually using acoustic measurements and say, all right, what happens if we pick 18 dB per octave on the subwoofer instead of 24? What happens? Or 6 instead of 12? And you look at the frequency response and what's going on between the speaker and the subwoofer. But again, that's the exception and not the norm. The norm is the best slope is the one that the speaker's rolling off at, and you pick that on the low pass side for the sub.
Is there any exception to open baffle speakers?
So what happens with that type of loudspeaker is when it has the radiation pattern is kind of a figure eight. It's a dipole type radiation pattern, figure eight radiation pattern, and when the bass wavelength becomes longer than the baffle on the speaker itself, you start to get phase cancellation, and the bass just falls off a cliff with that type of speaker. They are known for their musicality and transparency and nuance. They're not known for their bass response. So again, it would be really just listen to how deep does the loudspeaker get, and especially an open baffle loudspeaker like that, it's going to fall off a cliff and roll off very rapidly below a certain frequency, and that's where you want to set the low pass filter on the subwoofer and get the frequency and slope to match the loudspeaker. So really no different, other than the open baffle speakers do tend to roll off earlier, and not extend as deep as a conventional sealed or ported loudspeaker.
Yeah, it's very interesting that you say that, because in my experience, I have resorted to YouTube frequency sweeps, and the results are often quite surprising. I've had speakers come in here where, yeah, I mean, in the upper treble, in the mids, it's kind of interesting to hear. But that sweep as it goes down for a floor standing speaker, or even your more bookshelf styles, the variations that you hear in volume can be quite shocking, because when you're listening to regular music, it's like, oh, it sounds like what it sounds like. It sounds pretty good, or it sounds like this. And as it goes down, you will hear the volume go down to nothing sometimes and then come back so loud, as I think a lot of guys tune their stuff to kind of have like a little bit of foundation, right? But some of those ones in the middle that aren't so important, they're like, well, whatever, and they're gone. So it's like a cave and then huge bloom at the bottom. And that's the kind of thing where I think you get a lot of what you're talking about, these one note bass sounds, which is one of the things that happens so often, that I think as audiophiles or as people who are just interested in getting a really pure recreation, that we should try to avoid, but happens very often. I feel like one note bass sneaks up into the equation so frequently that it's something that you should always be kind of thinking about when you're thinking about these type of terms.
Well, what you're describing is the standing wave pattern in the room. So the room will support standing waves, which is basically, in layman's terms, it's the direct bass coming out of the speaker will strike the boundaries in the room and bounce back. And when it bounces back, there's going to be either a phase reinforcement with the bounce back and the direct output from the speaker, or there's going to be phase cancellation. So you end up getting this very ragged looking frequency response from the loudspeaker in room, and we just call that a standing wave pattern. It's very typical. There's actually 5 different types of standing waves in the room. The most common 3 obviously are your axial modes. There's front to back, side to side, floor to ceiling, and then there's also oblique and tangential. So if you've ever played billiards and you're thinking about, the ball bouncing off multiple surfaces on the billiard table, it's the same type of thing. So some of the standing waves can get quite complex, but if you walk around the room, you'll actually hear the bass getting louder and softer, and it's boomy and unbearable in some spots, and it's absent in other spots. That is not really the fault of the loudspeaker. It's the room itself. So sometimes the best way to attack a really bad standing wave issue is, one, look at placement. Try to move the loudspeakers into a location where their bass response sounds a little bit more benign and even-handed, instead of boomy and one note. You really want to avoid the standing wave peaks, because they're just unbearable. And then on the other hand, if you're sitting in a standing wave cancellation, you're not going to hear any bass at all. I mean, sometimes it's almost a perfect cancellation, and there's literally a hole in the frequency response, and the loudspeaker sounds terrible. So placement is your first challenge, to try and get the bass response even from the speakers. And also you can put bass traps in the room, and bass traps will absorb some of that energy that the loudspeaker's kicking out, and minimize the reflected energy back into the room. And then you get a little bit more even bass response and less bouncing around the room, and the decay times are lower, and all that. Ultimately below a certain frequency, the room won't support standing waves at all. The half wavelength is longer than the room itself, the longest dimension in the room, so the room just doesn't support standing waves. At that point, it transitions into what we call a pressure field. And if you walk around the room, the bass is perfectly even at every location. That standing wave peak and null and the uneven bass is gone. So eventually the subwoofer, which is really in the subwoofer domain, but eventually the room will transition to that pressure zone, and the bass becomes very uniform no matter where you are in the room. So when that occurs, what frequency that occurs, is really a function of the room size. But that's what you were referring to when you noticed that uneven bass. It's the room acoustics itself.
So you did touch on room placement a little bit there. Can you kind of lay it out for our listeners about all of your tips that you have for room placement? Because you guys have mentioned also too another term called room gain before we started. I thought was really interesting. How can you elaborate exactly on room placement? Because I know that a lot of people, when they think about placement for speakers, there's a very finite amount of places where you can put your 2-channel. Even, I mean, one might argue with the surround sound systems as well. But the subwoofer, I think, traditionally has been described as you can put it anywhere, behind a desk, behind a whatever, and that none of that matters because you only feel it. That's kind of like I think, a misnomer for some of this. What's your take on all that?
It is a misnomer. The subwoofer, unless you're low passing at a really deep frequency, and I would say, like, say 40 hertz, the subwoofer is directional because it's not like the low pass filter is not a brick wall. Even if we set it to 24 dB per octave, it is going to play bass above the filter frequency. So let's say you're trying to integrate the subwoofer with a pair of bookshelf speakers, and we end up setting the low pass filter at 60 or even 80 hertz if it's a fairly small speaker. Of course you're going to be able to tell where the subwoofer is in room. And so if I'm setting up a 2-channel system, I'll try really hard to get the subwoofer on the same wall as the loudspeakers, as close to the loudspeakers as I can. And again, we're really trying to think of the speaker and the subwoofer as a point source. They're in the same plane. We're shooting for time alignment. We're trying to get them to sound like one coherent speaker with a seamless transition between the speaker and the subwoofer. And that is often best achieved by placing the sub on the same wall as the speakers. And I mean, honestly, dual subwoofers, especially if you're into 2-channel, is a better experience because, again, the subwoofer is somewhat directional even at 60 or 80 hertz low pass frequencies. And to the extent there's stereo bass in the recording, you want the left subwoofer to handle the left bass and the right subwoofer to handle the right bass, just like you would with a loudspeaker. So running dual stereo subs in a 2-channel system really balances the sound stage. The sound stage opens up; it's much bigger. The subwoofer's impossible. You can't tell where it is in the room if you got 2 of them on the front wall near the speakers. And to me, that's the ultimate setup for a 2-channel system. And all my 2-channel stuff is set up with dual stereo subs.
Interesting. Because I feel like a lot of people get pitched the idea that, a sub is not directional. That is like the main argument for that idea, is that it's not directional even in the least. But if you're saying that, you want to pair it up like you already have a system, one for each side. It's being cohesive with the current setup of whatever you have going on. That seems to me to make a lot of sense, and that this ubiquitous placement of a sub doesn't really match up with the sound that we're going for as audiophiles, right?
Right. Now, say you're running a set of quasi full range towers in the system. They're solid down to 45 hertz or 40 hertz, and you're truly trying to integrate the subwoofer with those speakers. You would select a very deep low pass frequency, of course, because the speakers are getting down into the 40 hertz range in room. At that point, the subwoofer is non-directional. You can't tell where it is in the room, and you could probably get away with a single sub, even in a stereo system, and not lose that sense of soundstage and coherence. Again, because the wavelengths are so long and it's so deep, it's impossible for you to tell where the sub is in the room. The bass distribution is very even. The room's not supporting standing waves down in those frequencies, and you can get away with a single sub. But I would say that is the kind of the exception rather than the norm. The norm is you're running smaller speakers in a 2-channel system that don't extend down into the deep 40 hertz range, and it's more common to be low passing the sub at 50, 60, 70 hertz, and then dual subs becomes a much better option.
Now, you brought up the frequency range, and a lot of emphasis is put on the goalpost of 20 hertz. That's often referred to as the lowest part of the range that we can physically hear. What is your take on that range in terms of what the technical specs are often pushed out there with the speakers? But also, do you think that there's any merit to going lower than 20? Because can you, the question I often think about is, can you feel stuff below 20? Let's start there.
Oh, sure. That 20 hertz cutoff has kind of been rooted in audio for decades. It's not actually true. The human ear certainly can perceive frequencies deeper than 20 hertz. It's what we call threshold dependent. So it needs to be fairly loud for you to be able to physically hear it rather than perceive it. But we can hear frequencies below 20 hertz. So that's the first myth buster, I guess, if you will. Secondly, is extension below 20 hertz important? Of course. And the first thing that springs to my mind would be acoustic pipe organ. The 32-foot stop on a pipe organ is 16 hertz. And some pipe organs even have a 64-foot stop, which is 8 hertz. And so let's just look at the more common 32-foot stop on a pipe organ. Your subwoofer, if you do want to fully reproduce 2-channel acoustic pipe organ, needs to extend down to 16 hertz in room. And the sealed subs do a really good job of that because they take great advantage of what we call room gain. So if you recall earlier, we were talking about when the room transitions from this modal response where there's a bunch of standing waves and peaks and nulls to the pressure field where the wavelength is so long that the room doesn't support standing waves anymore, and the bass becomes very uniform throughout the room. Well, once you transition into the pressure field, the room starts adding free bass. It's just the physics of the room, and we call that room gain. And it is a transfer function. It's not a steady value. And in most rooms, it's maybe 7 to 10 dB per octave. In theory, the maximum amount of room gain is 12 dB per octave that the room will add, but no room is perfectly rigid and sealed, so there's going to be some losses. But anywhere from 7 or 8 to 10 dB per octave is what you're going to see from room gain. So let's say the room transitions to a pressure field at 35 hertz, and we measure the room gain transfer function at 8 or 9 hertz, which is an octave deeper. The room might be adding 10, 11 dB to the output of the subwoofer. It's just free bass. So room gain ends up extending the response of the sealed subwoofer in room much deeper than the quasi-anechoic frequency response chart would suggest, because we post those on our website. And you look at the frequency response of the subwoofer and say, oh, it starts rolling off at 32 hertz. It's 12 dB down at 20 hertz or whatever. If you stick that sealed subwoofer in a room and the room gain adds to the extension and output of the subwoofer, suddenly the subwoofer extends into the room, in room, to 15 hertz, 12 hertz, even 10 hertz. I've seen our sealed subs actually extend to 9 or 8 hertz in room flat if it's a really well constructed rigid room. So room gain is this awesome tool that we take advantage of. It's the natural acoustic phenomenon in the room. With our sealed subwoofers, we painstakingly craft the roll-off slope of the subwoofer to take maximum advantage of room gain. And so the sub ends up extending way deeper in room and having far more output at the deepest frequencies than you would otherwise suggest if you were just looking at the quasi-anechoic response on the website.
So what you're saying is, aside from resonant frequency, which could occur at a higher range than just the bass range, you're saying that the subwoofer shakes the room and the room shakes and it goes deeper.
Yeah, the room just starts augmenting the output of the subwoofer down deep.
And this is separate from a resonant frequency of the material of the room.
It's just free bass, and we take great advantage of it. So, to answer your question in layman's terms, is extension below 20 hertz important? Yes. Can our sealed subwoofers in the right room extend down to even 10 hertz, which is an octave deeper? Also, yes. And what you're going to perceive subjectively at those frequencies is more of a solidity, a thickness, a foundation to the presentation that is totally absent with just the loudspeakers running. Even if you've got, again, people call them full range towers. Really, they're not. Most towers get down to about 40 hertz or maybe even a little higher before they roll off. If you integrate a subwoofer properly into that system and get extension from 40 to 20, which is an octave deeper, and in some cases from 20 down to 10, which is another octave deeper, you have added 2 octaves of extension to that system. And it really adds that sense of pressure, foundation, solidity, in ways that you can't possibly comprehend unless you experience it. And sometimes it's subtle, and sometimes it's obvious. Like say you're playing pipe organ and the organist hits the 32-foot stop, that whole room will pressurize and it will throb, and you will feel like there's an organ playing in the room. And a loudspeaker can't possibly do that.
I just like to say it's also really fun to experience. That's one of the things I think I miss sometimes with headphone listening, is that sense of pressurization and the feeling of it. To me, it adds an element of entertainment to music listening that you just don't get with headphones. Headphones are great for resolution, and they got some fun stuff that you can do down there with the way it convinces your brain. But it's just not the same substitute, for me at least, as listening to something as you're describing with this really low visceral response to it.
Yeah, it's great. Sometimes you can feel the hair literally stand up on your arms, or you can feel a little bit of a waffling sensation in your shirt or your pants, just like you would if you were in a church with a full bore organ that's capable of pressurizing the entire listening space at 16 hertz. It's a pretty amazing experience once you've heard it. And even it's not even just isolated to pipe organ. I remember setting up a 2-channel system with Music Direct in Chicago, and we had a pair of Focal loudspeakers. Gosh, they were probably $20,000-$25,000 a pair, and they had pretty decent bass response. Everybody listened to the speakers standalone, no subwoofer. And I said, all right, give me 15 minutes. I'm going to integrate the sub and come back and we'll do another demo. And I think I ended up with maybe a 44 or 45 hertz low pass, very deep, because the speakers did have good bass. And level matched it, got everything perfect, got the phase set up, and then everybody came back in. And one of their favorite demo tracks was Eagles Hotel California, the live version.
Never heard it. I've never heard of that one. I gotta check it out.
and that was just kind of their go-to. And they said, "Can we play Hotel California live?" And I'm like, "Sure." So we played it without the sub, speakers on full range, and then we played it with the sub, and it was sort of subtle and painfully obvious at the same time that a subwoofer was running in the system. Again, and there's certainly not 16 hertz in that recording, but you got that sense of solidity, foundation on the kick drums and the tom-toms, the electric bass, that the loudspeakers were just sort of rounding off the low end, and they weren't fully capturing the undertones and the subharmonics on the recording. And once we got the subwoofer running, it was subtle but obvious at the same time that the sub was filling in those bottom, 1.5 octaves or 2 octaves. And everybody was like, wow, I never knew what I was missing. And then I just walked over and I powered off the subwoofer, just turned the power off, and the whole bottom end fell out of the presentation. And that was with the Focals running on full range. And everybody's like, man, these things sound suddenly thin, and they just don't have that low end that the sub has. So if it's properly set up, again, like we said in the beginning, our goal is to have that seamless transition from the speaker to the subwoofer. And when it's done right, you'd never know the sub was running until somebody walked over and threw the power switch. And you're like, wow, the bottom end just dropped out.
Yeah, I mean, I was only joking before. I'm very familiar with that track, and
Yeah, I was going to say.
intimately familiar. But you're right about the kick. So the bass drum comes in on that right away. It's like da-doom. And I've heard that track so many times in so many different scenarios. But one of the reasons they do that, they use it, is because there is information there at that bass drum thing that's not too shabby, right? Now, I'm not...
Oh, yeah.
And
Yeah,
when it comes
there's
in...
there's some pretty deep bass on that recording, and your normal, natural initial inclination would be, oh, the loudspeakers got that covered. It's not infrasonic, it's not pipe organ, it's not super deep synthesized bass. Of course the loudspeakers have this covered. But then you hear a properly integrated subwoofer picking up 1.5 or 2 more octaves, and you're like, oh, I guess they didn't really have it covered. That is quite obviously an improvement in the low end.
And yeah, just to elaborate on what you're saying, one of the things that it did take a while for me to fully comprehend was that you're talking about foundation, which is true. It has that feeling. You're talking about support and just the filling it out. But one of the things that I find very interesting about the way it feels, right, is that it adds stuff to the other frequency ranges. Now, I know that's not exactly true, but it fills it out in a way where they have these, there's a product called Sub Pack that is like a bass recreation vest that you can wear to supplement headphones. When you put the vest on, it doesn't necessarily like play music, but you feel it through bone conduction through your chest. But what it does to the music that you listen to through the headphone, it just sounds more full across the entire range. It's not just this sense of, oh, there's more bass, which I think can be a little bit confusing to some people. Oh, it's more bass. Well, you assume that with like, I think a lot of people assume that with the mid bass region, or these type of, when you just hit the bass boost on your CD player from when you were a kid. This sensation is more of like a visceral, full changing of the spectrum. But you're absolutely right. You notice it most when you have it and then you take it away. But it's not just the bass falling off. It's like the whole experience is kind of drained a little bit, which I think, if you nail right, is a really good reason to kind of make sure you're getting what you need out of the foundation, out of the bass range, all the way up. It's such a big influencer to the rest of the visceral experience of listening.
Well, it is, and it's interesting you bring that up because that is one of the most common positive feedbacks we get from our customers who integrate a subwoofer into a 2-channel system. They, almost to a person every time, the whole sound stage opened up. The system sounds bigger and wider and deeper, and I can't explain it. And I think it just has to do with the way the human ear processes the full spectrum of frequencies. And when you add that ultra deep bass to the presentation, even if it's just subharmonics, there's that sense of solidity and foundation that we process as being a larger listening space and a larger sound stage and a deeper sound stage. So it's almost a magic trick that adding the subwoofer can also enhance the mids and the highs in a way that you never really expected.
Exactly right. It's not that I feel like, oh, there's more mids or there's more highs, but it almost feels like a magic trick. It's like the way I perceive the music. I realize it's not changing the mids or it's not changing the highs, but my perception of that is enhanced in a very positive way if done properly, which I think is a great thing that a lot of 2-channel guys might overlook or not. So we talked about crossover settings and we talked about slope. But from my experience, there's a lot more to setting up a subwoofer than just those couple of variables we've already discussed. One of it is like strictly how do you connect the cabling? So, for example, some of the problems I've had is I'm turning the volume up on the amplifier, but the aggregation to the sub is not the same. I've also had a scenario where the sub was not properly hooked up. It was a fixed line output. and the subwoofer volume didn't go up at all. So I have it
Right,
like at a
yeah.
fixed setting always, and it's always the same bass, and then you turn up the thing separately. So how do we kind of alleviate that? How do you properly set up in terms of connections and settings on your amplifier a properly for 2-channel, and how is that different, and how can we do it right for a surround sound system?
Well, it's kind of funny. You've heard the old phrase, a broken clock's right twice a day. Um, if you're using a fixed level output, and I've actually seen that before, the system is right at one volume, right? It's like, okay, I got the loudspeakers that match the subwoofer at this volume, and it sounds good. So that's actually the most obvious first pitfall to avoid. Do not use a fixed line out. And they have a lot of different terms. It's like a loop back or a tape out or something along those lines. Those are fixed line level outputs. You don't want to use those. You need to use a variable line level output from the preamp or the integrated, so the subwoofer is seeing the same exact signal that the amplifier is seeing. And a lot of preamps will have a spare set of variable line level outs, and that's ideal. So you want to connect the left and right line level outputs from the preamp to the subwoofer so it's getting the same exact signal as the amplifier. If you don't have a spare set of line level outs, you can actually put a splitter on it. It won't hurt the signal at all. The input impedance on the subwoofer is very high. It's typically 25, 30, 40,000 ohms. So it's not going to be pulling any actual power out of the pre-out. So if you need to, you can split that signal and run a set of cables to the subwoofer and a set of cables to the loudspeaker amplifier at the same time. But again, if the preamp has two sets of line outs, sometimes it's got RCA and XLR. So maybe you can use one set for the loudspeaker amp and one set for the subwoofer. And some of our higher end subs do have both types of inputs, which adds a little bit more flexibility to the hookup.
When I notice there's always a pair of stereo inputs into the mono speaker, are those just summed together? Why is there a left and right channel for a single subwoofer, generally speaking?
Well, if some integrated and more modern preamps actually do have a sub out, and that would just be a summation of the left and right signals. And the assumption there is you're only going to run one subwoofer in the system, not two. So again, my preference is if it's a true stereo system, then I would want to run a discrete left to the left sub, discrete right to the right sub, just like you would do for loudspeakers. And then in that case, you'd be tapping into the actual left and right pre-outs from the preamplifier and not the dual, summed mono signal on the sub out. If you're only running one subwoofer in the system, then by all means tap into the sub out if it's there, because it doesn't matter. You need both. You need to capture both channels, and that's what the single sub out does if it is available on the preamp.
So is there any, aside from making sure you use a variable output pre-outs and not a fixed output, is there any other tips in terms of connecting it with cables in the physical connection?
Sometimes the sub out, and you're going to have to check with the manufacturer, sometimes the sub out is actually low passed electronically in the preamp or in the integrated. And that makes setup tricky because you've got an already low pass signal going to the subwoofer, and then you're doing additional low passing at the subwoofer itself if you need to. Sometimes these are low passed at 100 hertz or 80 hertz, and that may not be ideal for your particular setup. So it's always my preference in a 2-channel system to send the subwoofer a full range signal that is not low passed by the preamp, and then do all your low passing at the subwoofer itself. So that's just kind of a cautionary note, if you will. If there is a sub out on your preamp or integrated, you better check with the manufacturer and see, is this really full range? It's just both channels summed full range, or is it low passed? Because that does affect your approach when you're integrating the sub.
So far, we've really covered the two-channel stuff. Let's move slightly over for those interested in the surround sound system. Do you ever recommend two subs for a surround sound system? Is the idea mostly that it's low LFE, low effects, and these kind of things in a mono situation?
Well, in an AV processor, there is, of course, a dedicated sub out. And the way bass management works in an AV processor, it's all done digitally. And so let's say, for example, we're looking at a basic 5.1 system, right? So we've got left and right, center channel, right surround, left surround, and then a subwoofer in the system. So if you look at the audio track itself, the audio track actually has 6 channels. It's got left and right, center, right surround, left surround, and then what they call the LFE or point 0.1. A lot of people call it the subwoofer channel. It's really not. It is literally a separate audio channel on the soundtrack itself, and it's reserved for low frequency effects, and hence the term LFE. So that we call it the point 0.1 channel. And the LFE channel is actually silent for periods of time on soundtracks. It's not used all the time. It's used whenever the mixing engineer wants to use it. So the AV processor is seeing 6 channels coming in from the source. Let's say it's Blu-ray or streaming. And any of these channels could have deep, loud bass in them. It's not just in the LFE channel. There could be deeper, louder bass in the front, left, and right, or even the center channel. It depends on how the soundtrack was mixed. A lot of people would think, why would somebody put deep, loud bass in the center channel? Ask the mixing engineer. We don't know, but I've seen it. I can cite any number of soundtracks that have really deep, loud bass in the center channel. It's just the decision of the mixing engineer. So the purpose of bass management in an AV receiver is to apply a digital crossover to the speaker channels so they're not getting a full range signal. Because if the bass is that deep and that loud, it can actually damage the speaker, worst case, or even just overload it and make it sound like it's distorting and being overdriven. So we really don't want to send a full range signal to any of the speakers in an AV system because there's often demanding bass, the system's played louder. It's a very different animal than the 2-channel system we were discussing previously. So in the AV processor, you set up a crossover frequency for each channel, and that crossover frequency applies a high-pass filter to the loudspeaker, which we're not using in a 2-channel system. In a 2-channel system, we're just running the speaker on full range like we always have. We're just integrating the sub by low-passing it. But in the AV system, we're applying a high-pass filter to every speaker channel at the selected crossover frequency, and then we are taking the bass in those speaker channels and sending it to the subwoofer. And we're also sending the LFE channel to the subwoofer. So the subwoofer is getting what we call redirected bass from all the speaker channels and below the crossover frequency that you pick for that channel, and it's getting the LFE channel. So the subwoofer is getting a lot of content in the soundtrack, and by definition it's no longer stereo. It's just all these summed channels of bass. It's all the speaker channel bass and the LFE channel, and it's all being sent out the sub out. So the sub out signal is already low passed. There's no need to low pass it at the subwoofer. The AV processor is doing it for you. So that's why we disable the low pass filter at the subwoofer when we are when we're using an AV processor, because it's already low passed. So it's going to the sub. Now, to answer your question, why is it beneficial to use multiple subwoofers in an AV system if we're not talking about stereo bass anymore? Because we're not. You can't get stereo bass from an AV processor if you're using the sub out. So at that point, we're looking at you're adding dynamic headroom, and you're also combating the standing wave issue that we were discussing earlier. If there's one subwoofer in the room, if you walk around the room or sit in different locations, you can definitely hear that standing wave pattern where it's louder in some spots and weaker in other spots and boomy and bloated in other locations. I mean, you might even find a perfect location in the room where you can hardly hear any bass at all, and that's like a perfect standing wave cancellation. So it's very common in AV systems to add another subwoofer strategically placed in the room to even out the standing waves and result in a smoother bass presentation with better sounding bass at more locations in the room. So instead of just having bass great at one sweet spot in the room, you've got really good bass at multiple spots in the room simply because you have two subs, they're in different locations, the standing wave pattern is much denser with multiple subs, and then you get less variation with these peaks and nulls from the standing waves.
So real quick here at the end, what would you say is the number one tip from all the feedback you get from your consumers, you think, to get better sound from the integration of a subwoofer, would you say?
Well, for 2-channel, I would say the number one tip is don't set the low pass crossover, low pass filter at too high of a frequency, because then you're getting overlap with the speakers. And remember, we're sending the speakers a full range signal in a 2-channel system. If you truly want to integrate the subwoofer seamlessly, find out where the speaker rolls off in room and then set the low pass filter and slope at that frequency for a perfect seamless handoff. That is the most common problem I see, is someone will jack up the low pass filter to way high of a frequency. It's overlapping with the speakers. It sounds boomy. It sounds one note. You can tell where the subwoofer is. It's terrible. That's not the goal of a 2-channel system. So I'd say for 2-channel, that's the number one mistake, is not setting the low pass correctly. For AV, I would say the number one setup issue we see is after the auto setup is run in the AV processor, it will often select what we consider to be a non-optimal or incorrect crossover frequency for each channel. It will often sort of overestimate the bass capabilities of the speaker and set too deep of a crossover for that channel, or worse yet, it will set that channel to full range. And then we get back into, we're sending too much bass to the speaker, it's overloading it, it could potentially damage it. So the biggest tweak that we do for AV setup is to look at the speaker size and the crossover frequency in the AV processor to make sure that the subwoofer is getting all of the bass in the recording and the loudspeakers are not being overdriven or overloaded with too deep bass.
Ed, thank you. This has been very enlightening. I appreciate you joining us.
Yeah, thanks for having me, Brian.
The Occasional Podcast is a production of the Part-Time Audiophile Network, which includes PartTimeAudiophile.com, The Occasional Magazine, the PTA Newsletter, and AudioHead.com. You can stay in touch with us on Twitter, Facebook, Instagram, and YouTube. The Occasional Podcast is produced and hosted by Brian Hunter, executive produced by Scott Hall at PTA Productions. If you haven't already, please subscribe to The Occasional Podcast on iTunes, Google, Spotify, or wherever your favorite podcasts are downloaded.